Conditional probability. In this video, we'll take a look at the definition of conditional probability, its notation, and a formula that we can use to solve problems. We will also look at a few different type of problems that use conditional probability. The main thing I want you to get out of this is to see how to solve probability problems with just a few simple ideas and without relying on formulas unless we really need them. So, let's look at the notation first. Notation you might see like this, where it's P and then inside parentheses F and a vertical bar E. We read as the probability of F given E. So usually F is like the second of events, or at least not the first event. E is usually the first event. And then that might affect something and change the probability of my next event. Or another way to look at it is where instead of having everything being my sample set, I want to limit part of it and say, let's look at a subset of everything and pretend that subset is my new everything. Okay, what do I mean by that? Well, let's take a look at this chart. In this chart, we have the ages of males and females in some city, and given different ages. The first question I want to answer is, what is the probability a 0 to 18-year-old is female? And I want to write my notation first just so we get used to it, because sometimes we understand the notation but not the wording, or vice versa. So I have a question for you. Which one do you think will be correct? Should I put the probability of 0 to 18 given female? Or do you think I should write probability of female given 0 to 18 years old? Which one do you think is correct based on the wording? The probability a 0 to 18-year-old is female. Okay, so we're trying to find out female, right? And what do I know about this female? Well, I know that the female is between 0 and 18 years old. So the correct way to write the notation would be the second one. Was it probably of finding a female given, because I already know that female is 0 to 18 years old. So how do I do this? Okay, well, 0 to 18 years old is my new total. I'm given that. This is where I'm going to look, and only in this part here. So I want to look only 0 to 18 years old. And then I can do the probability like we've been doing in these last few videos, which is the probability is how many things that I want, in this case, females, 2286, out of the total 0 to 18 years old, 4426. You can simplify that if you need to. You put in decimal form with the calculator, but I like fractions so I can see where things came from. So the next part, what is the probability a male is 71 plus years old? So once again, we're limiting our everything. We're taking a subset. So what is my subset? Am I trying to see the column of males only and find out how many are 71 plus years old? Or am I trying to find 71 plus years old given that they're male? Well, hopefully you chose this one. 71 plus given that they're male, right? So what is the probability that I know a male, right, is this? This is the thing I'm trying to find. So once again, we're going to limit our domain, if you would, or we'll take a subset. And my subset now is going to be males. And then I want to find the probability out of this new total. My new total is 8103. How many of them are 71 plus years old? And it's 307. So the problem is not really difficult. I mean, it's really simple math if you can set it up correctly and know what they're asking for. So if you get a chart problem, this is the way that I would handle it. Now, a lot of problems in probability aren't chart problems. They're just kind of some word problems like this. And let me remind you from a previous video that we have multiple choices, multiple things or events that we're going to multiply probabilities. So I'm going to answer these questions without formulas, without notation necessarily, at least not formal notation. I'm just going to put the answers down using common sense and the fact that when we have multiple choices or multiple events, we're going to multiply the probabilities. So suppose that an animal shelter has 50 dogs and 40 cats. What is the probability of choosing 2 dogs? And even though I didn't write it in most of these problems, formally we're randomly choosing objects, or in this case dogs. I just didn't happen to write that, but I want you to realize that's what I'm doing, or what I should have in every problem. We are randomly choosing these things. So what is the probability of choosing 2 dogs? Well, even if we chose them at the same time, mathematically, we can pretend that we chose them one after the other. So I'd say, what is the probability of choosing a dog first? Well, of course, it's how many dogs out of how many total animals there are. Now, my second event or second choice means I'm going to multiply. And I think, well, how many dogs are left over if I've already chosen one? And the answer, of course, would be 49. Out of how many animals left over were 89. And that would be the probability of choosing 2 dogs. What is the probability of choosing a dog than a cat? So I could do really formal notation using the stuff above, this given that, but I think we can just use common sense here. So probability of choosing a dog is how many dogs out of how many total animals. Then I'm choosing something else, so I'm going to multiply the next probability. What's the probability of choosing a cat? Well, it's how many cats there are out of how many total animals are left over. Multiplying this, simplifying with a calculator, and you get the probability that you need. Although I like to leave it in unsimplified fraction form so we can see where things came from. Now I have a follow-up question here also. What is the probability of choosing a dog and a cat? Is that the same question as the one I just answered? Well, no, there's a subtle difference here. Because if I'm saying what's the probability of choosing a dog and a cat, it could be the probability of choosing a dog, then a cat, or cat, then a dog, right? So I have extra stuff going on here. And again, I'm going to try to use common sense here with a little bit of probability knowledge. So the probability of choosing a dog than a cat we just found, right? 50 out of 90 times 40 out of 89. Or I could have chosen a cat first than a dog. And what does or mean in probability? Hopefully you remember that means to add. Or I could have done a cat first, 40 out of 90, and then a dog times 50 out of 89. Notice that the order is different, but if you look at my fractions, they equal the same amount. And we'll talk about that later when we talk about counting techniques and some advanced probability problems. Let's do a really formal problem. And before I do that, let's talk about the formula. So the probability of finding A and B, right? If you recall from earlier, and in probability means we're going to multiply. So the probability of A and B, both of these things occurring, two choices, two events, is the probability of A times the probability of B, right? Given A. So this is the formal notation we use when there's conditional probability. That is when my second choice depends on my first choice somehow. Now, why do I show this formula? Because I'm not a fan of formulas unless I have to use them. It's because I kind of have to use it in this next problem. Suppose that 12.5% of all babies are preterm. 1.78% of preterm babies weigh more than 7.5 pounds at birth. What is the probability a baby weighs more than 7.5 pounds given it was preterm? All right. So we have a bunch of words here that I'm going to try to fit up here into my formula. So something in here is probability of A and B. Something up here is a probability of A. And something up here that is in my problem itself is a probability of B given A. Or one of these three things is the one that I'm trying to find. So which two are given and which one am I trying to find and how do I know? Okay. So if I look down at my question itself, this is going to help me set up things that I need. It's going to help me find kind of what A and B are. So I'm asking, what is the probability a baby weighs more than 7.5 pounds given it was preterm? Do you agree or not that this is my probability of B given A? How do I know that? Because it basically says it here, right? What's the probability of something given something else? So this is what I'm trying to find. Well, which of these things weighs more than 7.5 pounds or preterm is A? Which one is A? Well, from our notation, we know that this says the probability of B given A, right? So this is B given A, which means A must be the preterm. Let's go over that again just to make sure that makes sense for us. The problem is asking, what is the probability a baby weighs more than 7.5 pounds given it was preterm? Pretty clearly, I'm telling you that the given is the preterm, and since in my notation it's back here, A is the preterm. Which means what? It means that B must be weighs more than 7.5 pounds, right? Okay, so how do I set up this thing in my equation over here? First of all, do you agree that I'm trying to find this? I mean, that's what I asked for, right? So I could rewrite this equation in the following way. I could simply take my P of A and B, the left side, although I've moved it to the right now, and divide it by the probability of A, and that gives us what I want. So now all I have to do is plug in the values that I have and where I think they belong. So I know that A is preterm. What is the probability of being preterm? Well, I tell you up here, right? 12.5%. On top, this is the probability of both A and B. And look right here, the 1.78% is preterm and weighed more than 7.5 pounds. Even though I didn't put the word and in there, we can see the 1.78% is talking about both things being true. So the probability that I want is 1.78 over 12.5. And I will simplify this one down, which is about 14.24%. Now notice that we used a formula here. Did you see any shortcuts in the problem? Or if you see another problem like this, might you see shortcuts? But one thing I want you to get out of the problem like this, it seemed a lot more complicated when I had to use a formula than when I could just set things up, kind of using intuition and some basic understanding. But I did want to show you a problem where I generally have to use a formula. Let me give you one more problem, and a technique I like to use a lot when I'm solving probability problems, especially that are complicated. So in this problem, 100 circuits are shipped to a factory. 4 of them are defective. The factory manager doesn't know that. It randomly selects 2 circuits out of the 100 test. If one or more circuit is defective, the manager will reject the shipment. What is the probability the manager will reject the shipment? So in a problem like this, I really like tree diagrams. You don't have to do it. It just helps me organize. So I have a question for you. We do have multiple events. How many events or how many choices do we have? There are 3 numbers up there written out in numbers and not written in words. There's 100, there's 4, there's 2. Are there 100 choices? Are there 4 choices? Or are there 2 choices? If you said 2, you'd be correct. And here's how I know. I just use a slightly different word, but here's a synonym. We choose 2 circuits. So what I'm going to do is I'm going to build a tree diagram that has 2 levels. The first level is going to be my first choice. And the second level is going to be my second choice, given what happened in the first choice. So I am doing conditional probability. I'm just not doing it formally with formulas. So what numbers should I put on each branch? Well, on the left side, I'm going to put the probability of choosing a good circuit. So the first circuit that's chosen, do you see how there are 96 good circuits, because 4 are defective or bad, out of 100 total? So the probability of randomly choosing a good circuit is 96 out of 100, and the probability of randomly choosing a bad circuit is 4 out of 100. Now, pretend that the first circuit chosen was good. So I'm going to go down this side, that is the left side, and look at my second level, what is the probability of randomly choosing a good circuit the second time? Well, it's simply how many good circuits there are left, 95, out of how many circuits left over I haven't tested, 99. And what is the probability, if I chose a good one first, of choosing a bad one second? Well, it's simply how many bad are left over, all 4, out of how many circuits total left over, 99. Now, what if I had chosen a bad circuit first, going down the right side? What is the probability of randomly choosing a good circuit the second time? It's how many I want, 96 good, out of how many total, 99. If we chose a bad circuit first, what is the probability of randomly choosing a bad circuit the second time? Well, it's how many bad left over out of how many circuits total left over. So now let's answer the question, which says if one or more circuits is defective, the manager will reject the shipment. What is the probability the manager will reject the shipment? So I'm going to draw some paths down here. Let me choose red. So one or more bad could be good first, then bad. It could be bad, then good. Or it could be bad, then bad. So the probability of randomly choosing one or more bad circuits really could go down this branch, this one, or this one. So I could do the probability of this plus the probability of this plus the probability of the very last one. Do you see a simpler way to do this? If you thought complements, that's what I thought as well. So instead of trying to find the probability that the manager will reject the shipment, let's find the probability the manager will not reject. Because that is the complement of what we want. And the probability of not rejecting is assuming we have 2 good circuits. So the first one good, the second one good, and then multiplying those 2 things together. And we get the probability of not rejecting is 0.921. So the probability of rejecting is the complement, or 1 minus 0.921, which gives us a value of 0.079. So there is about an 8% chance that the manager will reject the shipment.